Hello everyone, Gigaraptor here with the third tutorial in the physics tutorials, and today we'll be covering scalars, vectors, and scientific notation, otherwise known in this context as standard form. So to begin with, we're going to cover a lovely little thing called scalars. You will have dealt with these most of the time you have been doing stuff in school. So scalars have magnitude only, so that means that they've only got one dimension really. So if you imagine something like speed, speed does not have a direction. It is only speed. It's not. So if I was to move something, say at 5 meters per second, you wouldn't know whether it was going north, east, south, west, or wherever. Same goes for something like distance, because you can move something 10 meters, but it doesn't specify where it is. So if you understand, scalar means magnitude only, and it's usually only one-dimensional. So because it's a scale, it's sliding scale, you know. So on the other hand, we have a little thing which you may have heard of called a vector. Vectors have two dimensions: magnitude and direction. Probably I'll underline that in a second if anybody's got the OCD that I have. The counterpart in vector for the scalar version of speed would be velocity. Velocity is simply speed with a direction. So if you had a speed of 10 meters per second, velocity would say it would be 10 meters per second east, for example, or 10 meters per second north or northwest, or whatever. Values don't matter, it just has a direction here. The version of this, the version of distance in vectors is displacement. Displacement is interesting because it is simply the shortest area between 2 points. So, for example, let me just show you an example. So, we'll do one side distance. Distance is simply scalar, so displacement over here. So consider 2 points, A and B. We'll call it A and B. We'll draw these over the other side here too, to represent the same thing. They might look like they're at different distances, but for all intents and purposes, they're the same. So distance, we could just be doing like this, like go completely crazy with the movement and all that. That's a valid distance. That's what distance measures. I'll probably make these bigger, just make them look more bold. Probably the same here. Whereas displacement would just do the shortest distance between 2 points. Understand? So displacement represents the shortest distance between 2 points, whereas distance is basically anything you say it is. So this could be like 100 meters, that could be 1,000, but there's still only 100 meters between them in that direction. Alright, so you understand, just to go over it, vectors have magnitude and direction, whereas scalars just have magnitude. So a vector would be something like velocity, whereas a scalar would be something like distance or something. Forces would be considered a vector because they're applied in a direction. Alright, so I think that's pretty much you covered. Unless you somehow misunderstand, just ask in the comments if you somehow don't understand that. I'll do my best to help. Alright then, so now we're on to, we'll call it standard form, because that's what we'll be covering and that's what we usually call it. But I don't know if Yanks, for example, call it scientific notation or what, call it standard form. So standard form has two proponents. It has a starting number, say 2.36, and then a second bit which specifies how many tens it is multiplied by, so let's say 10 to the 5. So what this represents is 2.36 multiplied by 10 to the 5, which would be about 100,000. So that would be about 5 digits. So it would end up with 236,000, because that's 5 zeros between the 2 and that. Because what you're doing is you've got, so 2.36 moving that up. So if we drew it over here, we'd move it 1, 2, 3, 4, 5 until it looked like that. That's basically standard form. So if we're going, adding standard form is quite difficult, and you probably could just use a calculator for it, because from what I understand, the mechanics exams and the physics exams allow calculators. So a lot of it is you can pretty much stop watching if your exam allows calculators for doing standard form, which I assume most people do. I'm not sure about, for example, the Ethiopian curriculum, but you know, I'll demonstrate multiplication and I'll demonstrate multiplication and division because they're quite simple and it helps to reinforce what you've learned about index laws in GCSE. So say we've got 2 times 10 to the 5. We're going to do multiplication to begin with, and then to multiply we're going to do, say, 4 times 10 to the 3. How we do this, I'll probably put these in brackets to make sure it doesn't look like 10 to the 5 has been multiplied by that. So how we do this is we take our first number here and multiply it by that. So 2 times 4 is 8. And then if you remember index laws, we take our index up here and we add them. When you multiply indices, you add them. So if you've got 10 to the 5 multiplied by 10 to the 3, it becomes 10 to the 8 because 5 plus 3 is 8. So we go like that. Viola. Or voila if you want to sound normal. If you wanted to divide something, say we had, let's come up with an easy number, 10 to the 6 times 10 to the 12, say. And if we're going to divide that by something, it's going to make it easy. 10 to the 9. What you'd do is you would simply divide this value here by this, so you'd get 2. And then, as you remember of index laws, when you divide the indices, they take away. So 12 minus 9 is 3. Are you getting it? Hope you understand, and you should get it. So let's take an example from from something we're not going to study in this particular one, but it seems like a good example. So if you're familiar with Young's modulus, which is stress over strain, that's often a common usage. That's a common example where we'd use standard form. I could probably come up with a better example if I spent more time thinking about it, but this seems like a good one. So it doesn't really represent very well how units carry across, but it seems like a good one since strain has no unit. So say we have a stress applied to an object of 2 times 10 to the 8. And it experiences a strain of, say, 2 times 10 to the 2. We do 2 divided by 2, so our Young's modulus would equal 1 times 10 to the 8 minus 2, which is 6. So that would be our Young's modulus in pascals. If you don't know what I'm talking about, I will do a materials one soon, I think. So that's just a reasonable example of how standard form would work in a practical sort of environment. I'll probably put this separate from the physics ones because this is applicable to pretty much all areas of science. Not too sure about chemistry or biology since I don't study them, but this is pretty applicable from what I recall. So that was scalars, vectors, and scientific notation or standard form. If for some reason you just had a narcoleptic attack and fell asleep at the moment you started it, I suggest if that happens you go about 9 minutes and 10 seconds to the beginning of the video and rewatch it. So thanks for watching. I'll see you on the next episode of the physics tutorials, and next one I think we'll be covering, I think it's actually finally doing verticals and horizontals of forces. So I'll thank you, and I'll see you later. Goodbye.